In 1999, NASA launched a mission that was supposed to change everything. But it ended in total disaster because of a single mistake that cost over $300 million. This is the story of how a math error nearly derailed the future of interplanetary exploration. Meet the Mars Climate Orbiter, a sleek 638-kilogram spacecraft designed to study the Martian atmosphere, weather patterns, and climate changes. Its purpose? To help scientists understand whether Mars could have supported life. It was part of NASA's Mars Surveyor 98 program, a critical step toward future manned missions. The mission wasn't just symbolic, it was strategic. NASA was laying the groundwork for an era of sustained Mars exploration. At the time, the space race had evolved. It wasn't about the moon anymore, it was about Mars. Multiple agencies across the world were aligning their missions toward the red planet, and the Mars Climate Orbiter was NASA's next bold move. It launched successfully from Cape Canaveral on December 11, 1998. After a nearly flawless 9-month journey to Mars, it was time to enter orbit. Everything had gone right until the moment it mattered most. That's where everything unraveled. The Mars Climate Orbiter was lost because two teams, one in the US and one international, used different measurement systems. One used metric, the other, imperial. Lockheed Martin, the contractor responsible for the spacecraft's navigation software, used pounds of force. NASA, meanwhile, expected inputs in newtons. To be specific, a newton is the metric unit of force. 1 newton equals the force needed to accelerate a 1 kilogram mass by 1 meter per second squared. Lockheed's software reported in pounds without converting. That's like sending a recipe in Fahrenheit to a European chef using Celsius. You'll ruin the dish, or in this case, a $300 million spacecraft. Nobody double-checked. No system flagged the mismatch. There was no automated unit validator, no human safeguard, just trust. That tiny difference sent the orbiter 170 kilometers too close to the Martian surface. That's like flying a commercial airliner straight into a mountain instead of cruising above it. It either burned up in the atmosphere or skipped off into deep space, never to be seen again. No telemetry, no signal, no second chance. The loss triggered a full-scale investigation. NASA had just poured $327 million into the project, more than the budget of some Hollywood blockbusters. In fact, it cost more than The Matrix and Fight Club combined. This wasn't just a scientific setback, it was a cultural gut punch for space optimism in the early 2000s. At the heart of the investigation was one haunting realization. This didn't have to happen. What they found was more than a unit error. It was a breakdown in communication, project oversight, and systems integration. Two teams speaking different technical languages, working toward the same goal, but never quite in sync. And in aerospace, being off by just a few units can mean catastrophic failure. The review board pointed to the lack of integration between contractor and agency teams. Documentation wasn't verified, assumptions weren't challenged, everyone trusted the numbers until it was too late. And this wasn't the first time NASA had seen warning signs. Earlier missions had near misses due to similar communication gaps. This was simply the one that tipped the scales. Investigators didn't just blame the numbers, they blamed the system. Different teams, across countries, working under separate assumptions. In an environment where precision and clarity are non-negotiable, that was a fatal flaw. The incident revealed something deeper, how bureaucratic silos and unclear documentation could be just as dangerous as equipment failure. But here's the twist. This failure led to a revolution in NASA's approach. NASA introduced sweeping reforms. Cross-check protocols became mandatory. Redundant systems were installed across all flight control operations. Contractors were held to stricter standards. International collaboration was restructured with unit verification checks embedded in every system. It even reshaped how private contractors work with federal agencies. Today, companies like SpaceX, Blue Origin, and Boeing all follow strict NASA integration protocols. Cross-verification systems and mandatory documentation practices stem directly from this one-mission failure. New software tools were implemented. Automated unit checks were made standard. No longer would assumptions go unchallenged. Every detail from units to execution had to be documented, verified, and tested. The changes were so deep that they extended into NASA's culture. Engineers were encouraged to speak up more, question everything, and assume nothing. In a way, that lost orbiter became one of NASA's most valuable teachers. The data wasn't recovered, but the lessons, they were priceless. Future missions like the Spirit, Opportunity, and Curiosity rovers were built on the back of that hard-earned knowledge. Each success carried the imprint of that failure, and the ripple effects didn't stop at NASA. The Mars Climate Orbiter incident is now taught in engineering schools, business programs, and systems management courses. It's a case study in failure, used to show how even elite organizations fall short without clear communication and accountability. Think about it. How many other missions came close to failure but never made headlines? Behind every successful launch are hundreds of quiet corrections made from past mistakes like this one. And not just in space, aviation, healthcare, military operations all began re-examining their integration processes after the publicized review of this failure. Space exploration isn't just about rockets and robots. It's about people, processes, precision, and humility. Because in space, there is no room for error. One small oversight can ripple across millions of miles and millions of dollars. But sometimes, it's the failures that push us forward the most. It's worth noting, today's missions to Mars, like the Perseverance rover or the planned Mars Sample Return mission, rely on these same protocol upgrades. If NASA hadn't learned from this failure, those missions might not even exist. This isn't just a story of failure. It's a story of how failure builds the foundation for progress. So the next time you hear about a mission going wrong, remember, it might just be what makes the next mission succeed. If you found this story fascinating, drop a comment below. What's another historical failure you want us to cover? And subscribe if you believe the past still has something to teach the future.